Hello students, in this video we continue with integrating factors. Already you know about integrating factor. If the given equation is not exact, then we can make it exact by multiplying with a suitable function. That is called integrating factor. Okay. There are some methods to find integrating factors. Already we discussed about two methods in the last video. Okay. Next, see the next method, method 3. Method 3, to find an integrating factor of IF means integrating factor of mdx plus ndy equal to 0. If 1 by n into dou m by dou y minus dou n by dou x is equal to f of x, a function of x alone, okay, a function of x alone, then e power integral f of x dx is an integrating factor of mdx plus ndy is equal to 0. Okay. If 1 by n into dou m by dou y minus dou n by dou x is a function of x alone, that means f of x, then the integrating factor is e power integral f of x dx. Okay. Next, method 4. To find an integrating factor of mdx plus ndy equal to 0. If 1 by m into dou n by dou x minus dou m by dou y is equal to a function of y alone, say some g of y, a function of y alone. Here g of y means a function of y alone. Then e power integral g of y dy is an integrating factor. IF means integrating factor of mdx plus ndy is equal to 0. Okay. If 1 by m into dou n by dou x minus dou m by dou y is equal to g of y, a function of y alone, then the integrating factor is e power integral g of y dy. Okay. See the problem. Solve x power 4 e power x minus 2mxy square into dx plus 2mx square y dy is equal to 0. Okay, see the solution. Given differential equation is x power 4 e power x minus 2mxy square into dx plus 2mx square y dy is equal to 0. Let it be equation 1. Now it is in the form mdx plus ndy. It is in the form mdx plus ndy equal to 0. Where what is m here? M is dx coefficient, that is x power 4 e power x minus 2mxy square, and n is dy coefficient, that is 2mx square y. Now dou m by dou y, the partial derivative of m with respect to y, treating x as constant. Now here x power 4 e power x derivative 0, this is completely x term. Okay. Here with respect to y derivative, y square derivative 2y minus 4m xy. Okay. Dou n by dou x, the partial derivative of n with respect to x treating y constant. Okay. Here x square derivative 2x, that's why this is 4mxy. This is minus 4mxy, and dou n by dou x is 4mxy. These two are not equal. Okay. Dou m by dou y not equal to dou n by dou x. Hence, given differential equation or equation 1 is not exact. Okay. Consider 1 by n into dou m by dou y minus dou n by dou x. That is equal to 1 by, what is n here? N is 2m x square y, and dou m by dou y is minus 4m xy, minus 4m xy minus dou n by dou x is 4m xy, 4m xy. It is equal to 1 by 2m x square y into minus 4m xy minus 4m xy minus 8m xy. Here mxy cancel, 2 cancel. This is minus 4 by x. Okay. Now say this is f of x, a function of x alone, right? 1 by n into dou m by dou y minus dou n by dou x is equal to f of x, a function of x alone. By method 3, the integrating factor is e power integral f of x dx is equal to e power integral. What is f of x? Minus 4 by x dx. That is equal to e power minus 4 integral 1 by x dx is log x is equal to e power log x power minus 4. Since n log x is log x power n, okay, that is equal to x power minus 4. E power log x is x, e power log x power minus 4 is x power minus 4. That is equal to 1 by x power 4. The integrating factor is 1 by x power 4. Multiply equation 1 or given equation by integrating factor. What is the integrating factor? 1 by x power 4. The given equation is x power 4 e power x minus 2m xy square dx plus 2m x square y dy equal to 0. Multiplying this equation by 1 by x power 4. That means all by x power 4 is all by x power 4. That is, now dividing by x power 4, e power x power 4 cancel, minus 2m y square y x cube. Here x cancel, okay, dx plus 2m y x square dy is equal to 0. Let it be equation 2. Clearly this equation is exact. Clearly equation 2 is exact, since we multiplied the given equation by integrating factor, and hence it is exact. Since this equation is exact, the general solution is the general solution of equation 2 and hence of equation 1, okay, is integral m1 dx. Now comparing this equation with m1 dx plus n1 dy, this is m1 and this is n1, okay, integral m1 dx y constant plus integral terms of n1 which do not contain x dy is equal to c. That is integral, what is m1 here? E power x minus 2m y square by x cube dx plus integral the terms of n1 which do not contain x. n1 is 2m y by x square, okay, this term contains x, that means there are no such terms. Integral 0 dy is equal to c. Now treating y constant, integrate this with respect to x. E power x integration e power x minus 2m y square constant into 1 by x cube is x power minus 2 by minus 2. 1 by x cube means x power minus 3. Its integration is x power minus 2 by minus 2 plus integral 0 dy is 0. That is e power x minus or minus plus 2 cancel here, my square by x square is equal to c. This is the required solution. See the next problem. Solve xy cube plus y into dx plus 2 into x square y square plus x plus y power 4 into dy is equal to 0. See the solution. It is in the form m dx plus n dy equal to 0. where m equal to xy cube plus y and n is 2 into x square y square plus x plus y power 4. So now dou m by dou y, the partial derivative of m with respect to y, treating x as constant, x into y cube derivative 3y square, that means 3xy square plus here y derivative 1, dou n by dou x. This is the partial derivative of n with respect to x treating y constant is equal to 2 into 2 constant, x square derivative 2x, that means 2xy square plus here x derivative 1 plus y power 4 derivative 0, since we are treating y as constant, okay, is equal to 4xy square plus 2. Now these two are not equal, dou m by dou y, therefore dou m by dou y not equal to dou n by dou x. Hence given differential equation or equation 1, let it be equation 1. Hence equation 1 is not exact. Now consider 1 by m into dou n by dou x minus dou m by dou y. That is equal to 1 by, what is m here? xy cube plus y, and dou m by dou x is 4xy square plus 2 minus dou m by dou y. Dou m by dou y is 3xy square plus 1, that is minus 3xy square minus 1. This is equal to 4xy square minus 3xy square, xy square plus 2 minus 1, 1, by taking y common here, xy square plus 1. Okay. Now xy square plus 1 cancel, 1 by y remains. Say this is some g of y. That means a function of y alone. Then by method 4, the integrating factor is e power integral g of y dy. That is e power integral, what is g of y? 1 by y dy is equal to e power integral 1 by y is log y, e power log y, that is equal to y. Now the integrating factor is y. Now multiply the given equation by integrating factor. Here integrating factor is y, that becomes xy power 4 plus y square into dx plus 2 into x square y cube plus xy plus y power 5 dy is equal to 0. Since you are multiplying the given equation by integrating factor y, okay. Now this is clearly exact. This is clearly exact. Since you are multiplying the given equation by integrating factor, okay. Now the general solution is, since this is exact, the general solution is the general solution of equation 2 and hence of equation 1, that is given equation, okay, is integral m1 dx, let it be m1 dx plus n1 dy, comparing with m1 dx plus n1 dy, integral m1 dx y constant plus integral terms of n1 which do not contain x dy is equal to c. What is m1 here? xy power 4 plus y square dx, treating y constant, plus the terms of n1 which do not contain x. Here y power 5, that doesn't contain x, that means 2y power 5 dy is equal to c. Now the integration is, treating y constant here, x square y power 4 by 2 plus xy square plus 2y power 6 by 6 is equal to c, or x square 3x square y power 4 plus 6xy square plus 2y power 6 is equal to some k. Okay, this is the general solution. Next method, method 5, to find an integrating factor of m dx plus n dy equal to 0. If m dx plus n dy equal to 0, is not exact and it is of the form x power m y power n into a1 y dx plus b1 x dy plus x power p y power q into a2 y dx plus b2 x dy equal to 0. Then where a1 b1 a2 b2 mn pq, these are all constants. Okay, then x power h y power k is an integrating factor of m dx plus n dy equal to 0, where h and k are obtained by solving the equations. Where h and k are obtained by solving the equations m plus h plus 1 by a1 is equal to n plus k plus 1 by b1 and p plus h plus 1 by a2 is equal to q plus k plus 1 by b2. Okay, h and k are obtained by solving these two equations. Okay, the integrating factor is x power h y power k when the given equation is of the form this. Okay, see the next problem. Solve xy cube into y dx plus 2x dy plus 3y dx plus 5x dy equal to 0. Okay, this equation can see the solution. This equation can be written as in the form of m dx plus n dy x y power 4 dx coefficient x y power 4 plus 3y into dx plus dy coefficient x 2x square y cube plus 5x into dy equal to 0. Okay, let it be equation 1. And this can be written as xy power 4 plus 3y into dx plus 2x square y cube plus 5x into dy equal to 0. That means m dx plus n dy equal to 0. Here m equal to xy power 4 plus 3y and n is 2x square y cube plus 5x. Now dou m by dou y. Check whether it is exact or not first. Okay, dou m by dou y, the partial derivative of m with respect to y. Y power 4 derivative 4y cube, that means 4x y cube plus here y derivative 1 3 dou n by dou x is equal to with respect to x derivative, this is 4x y cube plus 5. Now these two are not equal. Dou m by dou y not equal to dou n by dou x. Hence, given differential equation or equation 1 is not exact. Okay, this equation is not exact and it is of the form, given equation is of the form x power m y power n into a1 y dx plus b1 x dy plus x power p y power q into a2 y dx plus b2 x dy is equal to 0. Okay, comparing with this form, then we get m equal to m is 1 and n is 3. pq x power p y power q, there is no term x power p y power q, that means p is 0, q is 0. Here a1 is 1 and b1 is 2. a2 is 3 and b2 is 5. Okay, if the given equation is in this form, then the integrating factor is x power h y power k. Okay, if the the given equation is in this form, then the integrating factor is x power h y power k, and x power h and k are obtained by the equations m plus h plus 1 by a1 is equal to n plus k plus 1 by b1, and p plus h plus 1 by a2 is equal to q plus k plus 1 by b2. H and k are obtained by solving these two equations. Okay? Here m equal to 1, that means 1 plus h plus 1 by a1. a1 is 1 is equal to n plus k plus 1. n is 3 plus k plus 1 by b1 is 2. And the next equation is p plus h plus 1 by a2. p is 0. 0 plus h plus 1 by a2 is 3 is equal to q. q is 0. 0 plus k plus 1 by b2 is 5. That implies h plus 2 is equal to k plus 4 by 2. The first equation. And h plus 1 by 3 is equal to k plus 1 by 5. That implies 2h plus 4 is equal to k plus 4, and 5h plus 5 is equal to 3k plus 3. That implies 2h equal to k. 4 cancel both sides, and 5h is equal to 3k minus 2. Okay. From this, solving these two h and k, therefore 5h equal to 3 into 2h. Substitute here the value of h, k. Okay. Minus 2 implies that 5h equal to 6h minus 2, which implies that h equal to 2. Therefore k equal to 4. K equal to h, that's why k equal to 4. Therefore h equal to 2, k equal to 4. Therefore integrating factor is x power h y power k, that is x square y power 4. Now multiply equation 1 by integrating factor, that is x square y power 4. Then given equation becomes x cube y power 7 into y dx plus 2x dy plus x square y power 4 into 3y dx plus 5x dy equal to 0. That is, write this in the form of m dx plus n dy. This becomes x cube y power 8 plus, write the coefficient of dx, 3x square y power 5 dy dx plus dy coefficient 2x power 4 y power 7 plus 5x cube y power 4 dy is equal to 0. Okay, let it be equation 2. Okay, this is clearly exact. Clearly equation 2 is exact since we multiplied the equation by integrating factor. Equation 2 is exact. The general solution is, since this is exact, integral, let it be m1 and this is n1. This is in the form m1 dx plus n1 dy. Integral m1 dx y constant plus integral terms of n1 which do not contain x dy is equal to c. This is the general solution of exact equation. That is integral, what is m1 here? m1 is x cube y power 8 plus 3x square y power 5. X cube y power 8 plus 3x square y power 5 into dx, treating y constant, plus integral terms of n1 which do not contain x. What is n1 here? 2x power 4 y power 7 plus 5x cube y power 4. Okay, there are no such terms. Okay, each term contains x. That's why integral 0 dy is equal to c. Okay. Now integration with respect to x power 4 y power 8 by 4 plus x cube y power 5 is equal to c. Okay. Here integral x square is x cube by 3. 3 cancel, x cube y power 5. Here integral 0 dy is 0 is equal to c. Now this is the required solution. Okay. Okay students, thank you so much for watching. See you in the next